Psychologists study the mind and behavior, and one topic that's interested them for nearly 100 years is problem solving. By looking at 3 problems psychologists have studied extensively, we can get a little insight into how psychology sheds light on the mind. Again and again, psychologists have found that solving certain puzzles requires seeing things differently. In the candle problem, we're given some thumbtacks, a candle, and a box of matches. Don't try this at home without an adult present. The goal state is to attach the candle to a wall in such a way that we can light the candle without burning the house down. Again, don't try this at home. The 9-dot problem was published as a puzzle in the early 1900s, and it seems to have been first studied by the American psychologist Norman Maier in an article he published in 1930. The 9-dot problem runs as follows. Given 9 dots in 3 rows of 3, connect all the dots, drawing through them, using only 4 straight lines. The 3-glass problem involves 3 glasses, an 8-ounce glass, a 5-ounce glass, and a 3-ounce glass. We need to make 2 servings of exactly 4 ounces each without measuring and without just eyeballing or guessing. Most people start trying to solve problems using trial and error. This is seldom successful, but it does help you to explore what's called the problem space. The candle problem was the subject of a study by Gestalt psychologist Carl Duncker. In this case, the candle is very small, but a bigger candle wouldn't really help. The wax of the candle isn't strong enough to melt it and hold it to the wall. With the 9-dot problem, we can start exploring through trial and error. Making 4 lines, can we run through all the dots? It's easy enough to draw 4 lines, but they don't run through all the dots. We can explore the 3-glass problem in a sort of undirected way. If we pour liquid from the 8-ounce glass into the 5-ounce glass, then we have 3 ounces in one glass and 5 ounces in another. We can pour the 5 ounces back into the 8-ounce glass, and the 3 ounces into the 5-ounce glass. But we basically just keep rearranging 5 and 3 ounces in the various glasses. We don't have any way of getting to 4 ounces. The solution comes when we realize that the matchbox can be used to make a kind of shelf to hold up the candle. That is, it's not just a box, it's possibly something else. The inability to see the matchbox as a possible solution was what Duncker called functional fixedness, seeing an object as only performing one function and not possibly doing something new. Duncker gave his subjects a box of tacks. We're using the box of matches instead. When Duncker presented his research subjects with an empty box and the contents separately, they were twice as likely to be able to solve the problem. Researchers at Stanford found that solving the problem on paper, about 23% of students were able to solve the problem. When the phrase box of matches was underlined, or even just the word box, the success rate rose to 55% for those who had the phrase box of matches underlined, and 47% for those who had the word box underlined. The solution comes when we see things in a new way, from a new perspective or angle. One hint psychologists sometimes give test subjects with a 9-dot problem is that it's possible to go outside the square represented by the 9 dots. If we draw back a bit, we get a different view of the problem space. Psychologists still debate today why the 9-dot problem is difficult. Some problems are difficult because it's almost impossible to list all the possible solutions or pathways. The 9-dot problem is not this way. We can explore the problem space by seeing how few lines we can draw that pass through all the dots, not worrying about making one connected line right now. If we do this, there are at least 2 good ways to use 3 lines to cut through all the dots, and using diagonal lines we can do it in 4. If we look at this combination of lines, we can realize that 4 of them will connect outside the space of the 9 dots and give us our solution. As with the candle problem, seeing the problem a certain way prevents us from seeing the solution. One problem in our trial and error approach to the 3-glass problem was we were only thinking about what was in the glasses, not what wasn't in the glasses. If we keep track not only of how much is in the glass, but how much extra space is in the glass, then we can use that extra space to measure and remove quantities from the other glasses. If we pour 5 ounces out of the 8-ounce glass, then we have 3 ounces and 5 ounces. And if we pour liquid from the 5-ounce glass into the 3-ounce glass, then we end up with 2 ounces left in the 5-ounce glass. Combining the 3 ounces in the large glass and the small glass gives us 6 ounces in one glass and 2 ounces in another, which we can rearrange. Now we have 1 ounce of empty space in the smallest glass, which means if we measure 5 ounces into the middle glass and pour out some into the 3-ounce glass, we're left with 4 ounces. What's left in the other 2 glasses can be combined and must, of course, be 4 ounces. So what does psychology have to tell us about problem solving? Clearly, hints are helpful. It's also cheering to know that by combining elements of solutions that don't work, we can sometimes find a solution that does work. We think inside a frame or box. Indeed, the catchphrase, thinking outside the box, seems to have come from the 9-dot problem. In some cases, we literally need to see what's not there, empty space as a positive, not just as something to be ignored. Perhaps the most important takeaway is perspective. When we look, we often don't see that we're seeing things a certain way. Understanding how seeing is always a specific way of seeing can get us one step closer to that moment of illumination which takes us out of darkness.